Hey everyone, Actuary Dude over here, so let's look at another question. The force of interest delta t is a function of time at any time t measured in years is given by the formula, all of that. So the first part, calculate the present value of a unit sum of money due at time t equals 12, and we want to find the present value of a unit sum. Okay, cool, so I've taken the liberty of already finding what v of t is for the entire force of interest that we've been given. So let's start with the first part. In order to find the present value of a unit sum, well, we're not multiplying it by any sort of cash flow because it's just by unit sum. So all we really need to do is find v of t, and in this case, t is 12, so v of 12. And so in order to do that, all we have to do is sub 12 into the appropriate v of t, and in this case, it's the one where t is greater than 10. So if we sub 12 into all those t's, we'll find what v of 12 is, and the answer to part I. So let's work that out. I'll just bring this in a little closer. So we're just finding the exponential of, and I'll just put it in a few parts, minus 0.0025 times t squared, well 12 squared is 144, like that, minus there's 3 zeros, 1 times 12 cubed minus 0.15, close all the brackets. And that should give us, there we go, that's v of 12, and that is 0.5052. Okay, so I'll just note that down. 5052. Okay, so that's what the amount is. If you wanted to have a £1 or something, or one whatever, in 12 years' time, you just need to save this much money. And if you can invest it at this force of interest over the 12 years, then that's how much you need right now. Let's look at part 2. Calculate the effective annual rate of interest over the 12 years. So that's really saying if we've got some amount of money, in this case 5052, and we're going to multiply it by what interest rate over 12 years will give us one whatever. So let's have a quick look at that. In order to find that, we just got to find I. So I'm just going to say equals 1 divided by that amount that we started with, our present value, to the power of 1 over 12 to get rid of the to the power of 12, and then the whole thing minus 1. So we need an interest rate, an annual interest rate, effective interest rate as well, of 5.85%. So in this case, I equals 5.85% per annum. Alright, so far we've got 2 out of our 3 parts, which is most of the marks anyway. And now calculate the present value at time t equals 0 of a continuous payment stream that is paid at a rate of e to the negative 0.05 t per unit time between time t equals 12 and time t equals 5. Okay, so all we got to do here is we are finding the integral between time 2 and 5, and we're using the force of interest for that time. So e to the negative 0.04 t. We're going to multiply by the interest rate that they gave us, not the interest rate, the payment rate that they gave us, e to the negative 0.05 t. E to the negative 0.05 t, like say just dt over here. So in order to find that, we'll simplify that first. Between 5 and 2, that becomes e to the negative 0.09 t dt. What is the derivative of that? What is the integral of all of this? Well, that is the function itself. 0.09 t divided by the derivative of that function, negative 0.09. Okay, and then that's all within the 5 and 2. And then in order to find that, well, I'll just take out already 1 on 0.09, like that. And we're just going to find e to the negative 0.09 t between 5 and 2. So I'm just going to use Excel to find that bit. So over here, we've got equals. So I'm just going to say negative 1 divided by 0.09. That's this bit over here, multiplied by the exponential of negative 0.09 times 5 minus the exponential of negative 0.09 times 2. And close all the brackets for that. What does it become? 2.196. So there we have, that equals 2.196, which is approximately 2.20 pounds, whatever it could be. So that's the answer to part 3, 2.2. Second part, 5.85% per annum, and this bit is half a whatever, dollar, pound, whatever you're using. Thanks a lot for watching. If you've got any questions or want to know how I got to this bit, then please ask me.